All right, Chapter 7. Chapter 7 basically sets the table for the entire second semester, at least for 8, 9, and 10. 11 and 12 are a little bit different. So we kind of brush through this a little bit. There will not be a quiz or a test on Chapter 7. There will be Chapter 7 questions on the semester exam, which will be a double minor grade, but there will not be a separate quiz or test for Unit 7. And to be honest, we usually don't, even if it's not, because it's more about preparing us for the second semester. So here you go. So first of all, parameter and statistic. We've had this before. Parameters for the population, statistics for the sample. The letters start with a P or S. It should be pretty self-explanatory. Then they're going to ask you to pick out these items. So here we go. It says identify the population parameter, sample, and statistic. Pediatrician wants to know the 75th percentile for the distribution of heights of 10-year-old boys. So she takes a sample of 50 patients and calculates Q3 is 56 inches. Now, they do tell us right here, sample 50. They typically don't use the word sample in the problem if they want you to find the sample, but there's our sample, right? All right, and then the population is all 10-year-old boys, okay? And it says within the problem, we're trying to find, it's populate, who are you trying the information about? And then right here for parameter and statistic, parameter is for the population. This is kind of in general. So what are you trying to find in general? And statistic is what did you actually find within the problem from the sample. From the sample, it was 56 was where Q3 was. All right, next. We have a Pew Research poll asked 1,102 12 to 17-year-olds in the United States if they have a cell phone. 71% said yes. So the population is all 12 and 17-year-olds in the United States. That's who they're trying to get information about. Not the ones that have cell phones, but all 12 to 17-year-olds. All right, the sample is the 1,102 that we asked. Okay, then in general, we wanted to know the proportion of them that had, and that's going to be P, and that's the variable we'll be using a lot second semester. And the statistic P hat was the sample population of the sample proportion, of 71%. All right, so they'll ask you, maybe they won't ask you to do all four, but you'll be asked to identify certain pieces. It shouldn't be too bad. There's some homework problems. Make sure you practice them. All right, the next one, father has 4 sons with the given heights. Determine the sampling distribution of the sample mean for sample sizes of 2. So basically what we're doing is we're finding the average of any 2 of the boys at a time and finding the average of the 2 heights. Then I plot those on a line, and what's going to happen is the average of the average will be, in this case is going to be where these 2 are right here. And we've made it so that these are nice and neat. But X bar, this is the sampling distribution of the averages. So each of these X's represent an average. This is the average of the average. And what's weird is, or what's pretty good about statistics is the average of the average will always end up being the true population average, as long as you do your samples correctly, which is pretty neat. All right, the next thing is a difference in vocab. Distribution of a population, distribution of a sample, and sampling distribution. I've just copied this basically right out of the textbook. But the distribution of a population, I have 200 chips in a bag, 100 blue, 100 red. They're broken up 100 and 100 amongst the total population. The distribution of a sample is I have a sample of 10 chips from the bag, and here's the breakdown of 2 samples that I just randomly made up. And then if I take the distribution or the percentage of red chips, and then I spread those out, and I get those crazy examples where I had 9 blue and 1 red, but for the most part, the average of the average is going to be where the true average is going to be at. We know that it's 50%. The average of the averages is also 50%. All right, and then some symbols. For center, we have X bar and right here, unbiased estimators, biased estimators. The unbiased estimator is for center. X bar is the unbiased estimator of mu, and P hat is the unbiased estimator of P. Spread, there is not unbiased. Anything measure of spread is not unbiased. All right, here we go. How do you reduce the variable statistic? Reduce the variability of a statistic, increase the sample size, or more samples. If you do more samples, then you're going to get more of them in the center. But really, to be honest with you, the big one right there is increased sample size. That's something you'll need to know. AP exam, semester exam, lots. Reduce variability, increase sample. You can also stratify, but that's not what we're talking about. All right, then this last one, what effect does the sample size of the population have on the variability of a statistic? This isn't that big of a deal. It's just on this one, there isn't one. Again, there's a difference between the population size and the sample size, but it's the sample size that's important. All right, and then this last thing is the difference between precision and accuracy. All right, so we have this picture. It's right out of the textbook. It's really good. So we got a bullseye, and then we got where all the shots are. So high precision is these two. All of the shots are about in the same spot. This one has high accuracy as well. It's centered around the center, and everything is typed. This one has low accuracy. It's not at the center, but the precision is good. These two have weaker precision. This one is accuracy good. Everything is centered around the bullseye, but the precision is not. And then on this one, they're both messed up. That's the difference between precision and accuracy. All right. 7-1 notes, pretty short. Have a good night.